For example, let's take a simple example here. Let's say this question. We need to count the total number of 7s in 180 factorial. So I'll start with 180 divided by 7. I'll take the greatest integer of this, plus 180 divided by 7 square. I'll take the greatest integer of this, plus 180 divided by 7 cube. I'll take the greatest integer of this, till I get a 0 as my greatest integer value. So this will be equal to, let me divide 180 divided by 7. 180 divided by 7 will be equal to 7 2s are 14. I have 4 here and a 0, and 7 5s are 35. I'll have a 5 as my remainder. I'll put a decimal here, so I have a 0. 7 7s are 49 with 1 as the remainder, and this can be continued, but the point is I'll get a greatest integer of 25 in this case, because it's 25.7 something something. The greatest integer of this value will be 25. The integer closest to this value and lesser than that is 25, so we'll take 25 as its greatest integer. Now let me divide 180 with 49. 49, because 7 square is 49. So 49, I'll multiply this with a 3. So I'll have here 9 3s are 27, 2, 4 3s are 12, and 14, 147. So the remainder will be 3 and 3, 33. So I'll put a decimal here. So I'll have 330. But the point is I'll get some value here. But I can easily tell that the greatest integer of this quotient that I obtained here will be 3 itself, because it'll be 3 point something something, and the nearest integer lesser than this value is 3 itself. So I can directly take 3 as the greatest integer of this value here. Again, I have 180 divided by 7 cube. 180 divided by 7 cube. Now 7, what's the value of 7 cube? So 49 multiplied by 7. 9 7s are 63, 6 carried here, 7 4s are 28, 28 and 6 is 34, 343. So if I'll divide 180 with 343, I'll get 0 as a remainder. Not as a remainder, but as a quotient. So we need to stop this process the moment we got 0 as our greatest integer value. So we won't even count this. So our process will end in the second step here itself. So 25 plus 3 is equal to 28. So from this I can say that in 180 factorial, the number of 7s will be equal to 28.